We will discuss about issues associated with table-valued function usage in SQL Server. We will also see like how queries utilizing table-valued function goes for serial execution instead of parallel execution. I'll be using database AdventureWorks TW for this demo. I'll be creating two tables, table1 underscore temp and table2 underscore temp. Each of these tables will get its data from the underlying table called table1. I'm going to create a function called func underscore table1 underscore column4. So this function basically takes a parameter at column 4, which is in date time, which has a date time data type, and basically returns a date time value. So what it basically does is like this function basically compares the parameter value with the get date value, and if the value that the parameter is having is lesser than get date, then it basically decrements the day as far as the date value is concerned by -1, and then this particular data is sent across to the calling select query or any other query. Now, for example, let's consider like at column 4, the parameter for this function contains a value of 23 January 2023. Then what happens is like this value is compared with get date. Since 23 January 2023 is less than 24 January 2023, which is today, what will happen is like the next query, basically what it does is like it subtracts -1 from column 4. So what happens is like 23 January 2023 will become 22 January 2023, and then this particular value will be sent across to the calling function. Now let's look at this particular query. I'm enabling statistics time on, and then at the end of the query I'm disabling it. This particular query involves table1 underscore temp and table2 underscore temp. So what I'm basically doing is like I'm basically selecting table1 dot column1, table1 underscore temp, column2 and column3, and then basically passing this table2 underscore temp dot column4 to this function func underscore table1 underscore column4, and then we are joining table1 and table1 underscore temp. The joining condition is like column1 for each of these table, and then we are joining table2 underscore temp, and then again the join condition is column1 between table1 underscore temp and table2 underscore temp, and then we are ordering the result by table1 dot column1 and column3. So this is the query. So let's enable the execution plan and let's execute this query. If you see, this query takes close to 4 seconds if we look at it, and it returns close to 118,890 rows. And now if I look at the execution plan, what I'm basically seeing is like we have table scan happening as far as table 2 underscore temp and table 1 underscore temp is concerned, and table 1 we have a cluster index scan, and then the join between table 2 underscore temp and table 1 underscore temp as a hash match, and then we sort the record, and then we send it across the data to merge join, and then this merge join basically hands over the data to the select operator, and it gets displayed to on the SSMS. And now if I look at it, what I'm seeing is like we have spent close to 1.4 seconds on CPU, and then we have an elapsed time of close to 4.1 seconds. And now if you look at the execution plan, even though we are dealing with 118,000 rows on each of these operators, what I'm able to see is like we don't have parallelism. So there is no parallelism for any of these operators. On the other hand, what I'm seeing is like since we are using this function, what is happening is like the estimate seems to be low, kind of like the SQL Server optimizer feels like it doesn't require parallelism, and that is the reason it is basically going for a serial execution. But now what I'm going to do is like I'm going to replace this query, instead of using the function, I'm just going to rewrite this query and use the case statement, wherein in the case statement I'm just checking directly whether c dot column 4c is your table 2 underscore temp is less than get date, and then I'm basically decrementing the value of the day as far as column 4 is concerned. And then in case if it is greater than get date, it basically displays table 2 underscore temp dot column 4 as it is. So this is same as what we have as far as the function is concerned. Instead of having a function, I'm directly putting that business logic into that query. So if I run this query, what I can see is like this query now completes in 1 second. It is not taking 4.2 seconds. Instead, it is taking 1 second. Now, if I look at the execution plan, the first thing that I can see is like all the operators here are going for parallelism. If you see this, we have this parallelism enabled, and each of these operators has got the parallelism enabled. Yep. And what other things that I'm seeing is like I'm going for hash match everywhere. I'm not going for merge join here. Instead, I'm going for a hash match. And if I look at the stats here, what I'm able to see is like I'm completing everything. The CPU time utilized is like 355 milliseconds. I'm not using 1.2 seconds of CPU, and also like I'm not using 4.2 seconds of execution time. I'm just using 894. It's like an 5 times improvement as far as the execution time is concerned. Like we are able to improve it as soon as we stopped reusing this function, and then we are instead of putting using the function, when we use the logic directly on the query, what I'm able to see is like this is performing very well. Now we will run these two queries at the same time and then check the statistics info side by side. So let's execute it. Let's wait for this query to complete, and then we will compare the execution plan, and then we will look at the stats information. So what I'm seeing is like we have an index recommendation for both the queries. The index recommendation is same, wherein it is requesting us to create an index on column 1 for table 1 underscore temp and include column 2 and column 3. I'm not going to create that, but I just want to update that. And as far as the execution plan is concerned, if you see here, the execution plan is nearly same. It is just like we don't have this sort and merge join. Instead, we have an hash match here. So and also like if you look at each of these operators, we have parallelism enabled here, but we don't have parallelism enabled on this one. And if you look at the stats information, what I can see is like the first query, which uses the function, takes close to 1.8 seconds of CPU and then 3.9 seconds of execution time. But the second query basically takes 437 milliseconds and 799 milliseconds of execution time. So as far as CPU time is concerned, we are like improved it by 4x, and then as far as elapsed time, the execution time is concerned, we have improved it by like 4 or 5x times. So there is an overall improvement. The main reason why we use function, the developers basically wants to reuse the code. So instead of repeating the code again and again on the queries, they tend to use functions. But sometimes what happens is like, at least like what I have seen is like function usages actually have some estimate issues, and then it brings down the overall performance. And scenarios like this specifically, I can see that changing the function and not using the function, instead bringing in the business logic direct to the query, if it is improving the queries by 4x or 5x, I think we should definitely go for having the business logic written directly on the SQL Server query instead of going for a function to reuse the code. That's it for this video. Thanks for watching. Have a great day. Jai Hind.